Good morning, dear children. So in this video we are going to see the next one, that is equations of motion. Okay, so Newton, he studied that motion of an object and he derived three set of equations. These are the three set of equations relating velocity, acceleration and distance. Okay, so we all know first one, that velocity is nothing but the rate of change in distance, right? So velocity is equal to distance or displacement by time. So velocity, it is a vector quantity and the SI unit of velocity is meter by second. Okay, so what is acceleration? Acceleration is nothing but that rate of change in velocity, that is change in velocity by the time. Okay, so acceleration, that SI unit of acceleration is meter by second square. That and all we already know. So now now we are going to derive these three set of equations. These set of equations which relate this velocity, acceleration, time, distance. Okay, so now we are going to derive these sets of equation using graph. Okay, using graph. From graph we are going to derive these three equations. Okay, so here u is the initial velocity and v is the final velocity. Then a denotes that acceleration, t denotes time, then s denotes distance or displacement. So see, the first equation, v is equal to u plus at. Second equation, s is equal to ut plus half at squared. Then the third equation, 2as is equal to v square minus u square. So these set of equations are called equations of motion. So now we are going to derive these three equations by a graph. So consider an object as in uniform accelerated motion. So that object starts from the point D with the velocity of u. Okay, with the velocity of initial velocity of u, and it reaches the point B. See, this is the point B. It reaches the point B. So here that motion is uniform acceleration motion, because that velocity increases with the time. Okay, so here see, the what is that initial velocity? Initial velocity is u. So that object started from the point D and reaches the point B. Now we are going to plot a graph. For this you have to take the time along the x-axis and velocity along the y-axis. Okay, so here that motion is a uniform acceleration motion, no? So we can get a straight line like this. Okay, we can get a straight line because the time increases means that velocity also increases, so we can get a straight line. So that velocity for this reaching point, you can take an as c. Okay, so at that particular point B, the time is taken as E. See, we can take the time as E. So from the graph, we can say that what is that initial velocity? Initial velocity is equal to OD. So this is the origin. So this is that starting point. So first initial velocity is OD. So it is equal to EA. Okay, so it is equal to EA. Then final velocity is equal to OC. So this is the final velocity, right? So this is the ending point. So the velocity for this ending point is c. So what is that final velocity? OC. So OC we can write as EB. So V initial U initial velocity is equal to OD. That initial velocity U is equal to OD. That is, it's equal to EA, right? So see that final velocity is equal to OC. It's equal to EB. Okay. So what is the time? Time is OE, what is the time? That is OE. This is the time, no? So, OE, it's equal to DA. So, we can write these from the graph. Okay. The next, this DC, it's equal to AB. DC is equal to AB. So, you just mark the things from the graph. Now we are going to derive the first equation from this graph.